Hello and welcome to this first video on polynomials, and in this video we're going to look at how do we divide a polynomial expression by a linear expression. So first of all, given that x plus 1 is a factor of 2x cubed plus x squared minus 7x minus 6, factorise that expression completely. So what that is going to tell us is when we fully factorise this, we are going to find that one of the factors is x plus 1. So if we divide this by x plus 1, then we will get what we need. So I'm going to write 2x cubed plus x squared minus 7x minus 6. And I'm going to do it in like a bus stop, like we would do with short division, but I'm going to write the x plus 1 factor on the outside. So when I divide x plus 1 into this, the method we're going to use is, first of all, we are going to take this first term of x and we're going to see how many times that goes into 2x cubed. So I'm going to do 2x cubed divided by x, which is going to be 2x squared, and I'm going to multiply 2x squared by this term here, or this expression here. So 2x squared times x is 2x cubed. 2x squared times 1 is 2x squared. And what I'm going to do is I'm going to subtract that from the original expression. Now you will always find that these two terms are equal. So when we subtract them, we always get 0. That must be the case. If you do not get that, you have made an error. So x squared subtract 2x squared is negative x squared. Negative 7x take away nothing is just negative 7x. Negative 6 take away nothing is just negative 6. And what I'm going to do now is I'm going to repeat this process for the remaining terms. So negative x squared divided by x is negative x. Multiply through by negative x. And subtract it. So that becomes 0 again. Negative 7x subtract negative x is negative 6x. Negative 6 subtract nothing is negative 6. And then when I get to the end here, I've got nothing left over at all. So I can now partially factorise this. So I've got x plus 1 is one factor, and this quadratic expression up here is another factor, but it asks me to factorise completely, and that is because 2x squared minus x minus 6 can also be factorised. Now I'm not going to go through how to factorise a quadratic as part of this video. There are other videos on my channel that you can find that will help you do that. But if you're looking at this particular unit, then this should be a skill you already have. So this will factorise to give us, must be positive, no, negative 2 there, and positive 3 there. And now that's fully factorised. So we've got a second example here. Now this one is very, very similar, but there is one key difference with the way we approach it. And that is because we've got our highest power of x is x cubed again. We've got a term with x squared. We have no x term. But when we do our division, so when I draw this out, we've got my x cubed, my 3x squared. I need to write in a 0x term. If I do not write out a 0x term, then I'm going to have a gap when I try and start dividing this, and it's going to cause me a space issue. So let's work through this. So x divided into x cubed is x squared. Multiply through by x squared. So actually, when I subtract this, that just becomes 0, and that just becomes 0. 0x take away nothing well, that's just 0 as well. And I'm left here with 1. Okay, now x isn't going to be divisible into 1. So what I've got left here is a remainder. And you always know what you've got left as a remainder is if the power of x of what is left over is smaller than the highest power of x up here. Okay, so I've got a single x here, so x to the power of 1. This is no x's, so it's x to the power of 0, so that's a lower power of x. This is a remainder. So divide this by x plus 3. I've ended up with x squared remainder 1 when I've done that division. Okay, if you'd like to have a go at these questions, feel free. And then here are the answers. And then there's 2 sets of questions here you can have a go at. And here are the answers to those questions. So hopefully you found this useful on polynomial division useful, and we'll join us again for the next video in this series